Hello. This video focuses on the seismic resistant design of a tall building. It is made as a part of assignment of final project on the design of tall building for the online course of Skyfi Labs. In this video, I'll be focusing mainly on the seismic resistant design of the buildings. This is the same building which has been already analyzed and designed for dead live and wind load in the first video posted by me. So in this video we'll be doing the seismic design by mainly two methods. First is response spectrum method and second is time history analysis. So first we'll be doing response spectrum method, which is a linear dynamic analysis, and it provides a maximum seismic response of the structure by measuring the natural mode of vibration. So for doing this, first of all, unlock the building as I have already done it. Now we have to define seismic load. Go to define load patterns and we have to add seismic load here. From the drop down menu, also select seismic. Auto lateral load, modify it as IS 1893-2002, which is the Indian standard for seismic design of building. Add new load. Now by selecting the same seismic load, go to modify lateral load. Now in this we have to select X and Y directions both, and we are not taking eccentricity right now into account. As the building is situated in Bangalore, which is in zone 2, the seismic coefficient for it is 0.1. Site type is 2 as per IS 1893 and importance factor for residential building is 1. The response reduction factor is taken from IS 1893, it is 3, and the time period is program calculated. Press OK. Now this load is added. Now select OK again. Now we have to go to define menu and we have to define the function. So we'll be defining the response spectrum function. We have to choose function type to add. Now in this again we will be adding IS 1893 2002. Add new function. Give the name as response spectrum function and give the parameters appropriately as per the building. Seismic zone factor 0.1. Soil type we have already assumed medium type of soil and all the parameters are okay. Press OK. Now the response spectrum function is defined. Now press OK. Go to define, go to load patterns. This is already done, we have seen. Now go to define, see load cases. Now we can see that there is a seismic linear static load already there. Now before setting the load case, we have to check the units of the acceleration. So go to options, display units. In this you can see the units are displayed and check acceleration. As we can see the unit is millimeter per second square. Now we will be adding the new load case. Go to load cases, add new case, give the name as response spectrum. load case type, response spectrum, and then add acceleration in the u1 direction function is, and the scale factor we have to consider the units. Based on that units millimeter per second square, the scale factor depends on I, G and R, and it is calculated as 1633.5. Now the motion is in two directions, so we will be giving name as U1 and U2, and the scale factor is same, 1633.5. Now rest of the things are, leave them as it is, click on OK. So a new load case response spectrum is added. Now click OK. Now the seismic load is applied. We have to run the case now. Now for this load, seismic load, we don't have to select any building because it is applied on whole of the building. So we'll go to Analyze, Set Load Cases to Run. As we are doing only seismic and response spectrum method, so we will be not doing dead end analysis for dead end live case. So select dead end live and do not run. Action as do not run. So we'll be doing analysis for only seismic load here. Now run now. It will take some time. As it is a big building, it is taking some little time. And after the analysis is complete, the 3D view will be showing the displacement, seismic displacement. As we click on any element, we can see the different displacement value, the displacement in x direction, y direction, z, and rotation along with that. Now we have to design the same building. So we'll go to Design, Concrete Frame Design, check that the design is done by IS 456-2000. Okay. Again go to Design, Start Design Check. Now design is being done and it will take little time. Now the design is complete and the 3D view shows the longitudinal reinforcement. We can right click on any member and you can see the table that this beam is B14, the section is 500 by 300, top steel, bottom steel, shear steel. So we can get the details for all the elements from here. This E-type software also has a 3D view. So we can right click on any member and you can see the table that this beam is B14, the section is 500 by 300, top steel, shear steel. So we can get the details for all the elements from here. This E-type software also has a 3D view. So we can right click on any member and you can see the table that this beam is B14, the section is 500 by 300, top steel, shear steel. So we can get the details for all the elements from here. This E-type software also has a option of giving the reports. So go to report section, we can see the project report and summary report. But because this is an evaluation version, we cannot print out the report. So if we go to summary report, the tab software will prepare the report. It takes little time, and in the project report everything is there, all section, material properties, reinforcement, as we can see. All summary reports is here. Now the same building we'll be doing by uh, time history analysis. So for doing that time history analysis, we'll be first unlocking the building so that we can add new load to it. Now go to define, go to load patterns. The see that the seismic load is already defined, but now we have to modify the seismic load, and let us consider that we are considering only x direction. The rest of the factor will remain same as it is same building located in Bangalore. Now click OK. For doing the time history analysis, it is a non-linear dynamic analysis. It provides the structural response of the structure with respect to ground motion record. This method can be used only when time history record of a particular location are available, because in this we need the real ground motion. So, but for this building we will be using only the Bhuj earthquake records of Bhuj for 2001. So let us add new function. Sorry, we have to take a file, choose function type to add. We have to take from file. This file is the record, time history record of the building. So from file we can browse the computer. I have already downloaded this file, and we'll be importing it here. It takes little time. So the file is here. Now header lines, as we have checked earlier, there are none header lines which are to be skipped. Number of points is 1, and the format is fixed. Let's say 10, and give a name to this function. Let us give a name as time history. And press OK. So the function is added as time history function. Okay. Now we'll go to define load cases. We will first delete the response spectrum case. Let us delete it, and we'll add a new case. Time history. Select time history. Add load pattern, acceleration, U1, default time history. and scale remains same 1633.5. Rest of the things remain same. Click OK. The time history case is edit. Now we again have to run the case as we did earlier. Analyze. Sorry. Set load cases to run. Same we are doing the seismic and time history analysis, so we will not be running dead and live load cases. Run now. So as you can see, this is the display shape. We can zoom in, zoom out. And by clicking on this, we can get the displacements. Now we have to do the design for this case. Again, go to concrete frame design, start design check. It will take little time. The online course of Skyfi Lab is really wonderful as the videos are very systematic and methods are explained in very simple language. Now it is saying analysis and design section report for 15 concrete frame. Do you want to reiterate design? So we'll press yes because this time we have taken auto select properties. So the program has an option of doing reiteration with the next set of properties instead of going to the defining new properties every time. So auto select that way is more beneficial. Now it is again doing the design by taking improved set of properties. So now the design is complete and this shows the reinforcement at different elements. So we can pan it and right click on any element will give us the sorry, reinforcement. So this is a table B5 story 18 section name and the reinforcement is listed here. So this way we can design our building with ETAP software easily. And thank you very much. Even we can take the report from ETAPs directly. I thank Skyfi online course for explaining this design of building in a very lucid and simple language. Thank you very much.